In the previous video in this series, where I'm restoring this LRP-300 paper tape punch and reader, I reconditioned and restored the punch head. We completely dismantled it, checked the pins, checked all the solenoids. I replaced one of the drive belts, readjusted everything, and ran up the motor, and it all seems to be running fine. I did test each individual solenoid to make sure it was operating, and as you can see, I've now refitted this to the main chassis. So it may need realigning with the top cover once I get around to refitting that, but I'll do that in a future video. At the moment, the next step is to look at the electronics. So to do that, we need to look at the board, and this is a discrete design. There's no microprocessor on here, so I tend to approach repairs and restorations of electronics like this in a slightly different way to microprocessor driven systems. So the first thing I'm going to do is just check across the power rails to make sure that none of the caps are shorted or there's no obvious shorts across any of the rails. There are quite a few tantalum caps on here. They're not all across the power rails. Some are used for timing circuits, so I suspect there may be some issues there as well. But the first thing I want to do is make sure these aren't going to self-destruct when I apply power. I won't do that on camera. All I'm going to do is use a multimeter and check across the power rails to make sure there are no shorts. Once I've done that, I'll get it temporarily fitted back into the chassis. This chassis is quite nice in that it lends itself quite well to allowing us access to the electronics once we've fitted the board. Sometimes you can't do that and you have to make up extension cables or find some workaround. This is quite nice. I can put the board into the chassis and we can still access pretty much all of it. And what I'll do then is I'll hook up the various cables. At this point I will hook up everything to make sure that when I power the system up, I haven't got anything obviously wrong with it. Now this is kind of the opposite way around to the approach I normally take with more complex microprocessor systems, but that's how we'll start with this one. I kind of suspect it's not going to work straight away, but I'll get it all hooked up, we'll power it up and see what happens. Okay, I've got the board temporarily fitted to the chassis. I've reattached the control board. It just connects with a pin header along the front here, and I've got all the cables connected for the punch head, speed sensor and that sort of thing. The only thing I haven't fitted is the reader. It doesn't need that to do the initial testing, and the punch should still work without it fitted. So what I'll do now is power this up, and hope, fingers crossed, we won't get a lot of smoke and noise. Okay, now it's probably not evident from the camera, but all the pins are moving in the punch head, so they're all continuously trying to punch the paper, and of course they shouldn't be doing that. So what I'm going to do until we done some fault finding on that part of the system is I'm just going to unplug the solenoid connector, and that way I can run the system without wearing out the punch head. So I'll just get that connector removed. Okay, so I have the solenoid connector unplugged from the board. The system doesn't sense the solenoid current, so it's not going to know that's unplugged. It's going to continue trying to drive the punch in the same way it should do normally. It's just going to stop us continually driving the pins up and down. I did check as well while I was, or just before I unplugged the cable, and the solenoids were all energized. So it's not an adjustment problem with the punch head, it's actually the solenoids being energized that's doing that. Not that surprising. I doubt this board is actually running, but next thing we're going to do is do some basic testing of the electronics. So I'll just rearrange the unit a bit so we can see the scope and the board at the same time, and then we'll get back on camera. Okay, so I thought a good place to start would be with the baud rate clock generator, so we'll start with that circuit. Now luckily I do have the schematics for this, so it's going to make life an awful lot easier. And you can see it's quite a simple circuit we have here. It's just two 555 timers set as oscillators, and all the baud rate select switch does is select one or the other, and we've got an OR gate, and then with this it's just used to give us an even marked space. And there's a nice test point here that we can use. If we need to, we'll go back through the circuit, but we'll look at this point and see if we're getting a clock. So we'll find that on the board, and that is down here. Okay, so when I apply power now, what should happen is we should get a clock shown on the scope, and the two speeds this I believe is set to is 300 and 110 baud, that is. This machine can be adjusted. It's kind of an analog adjustment almost, where you can adjust it to pretty much anything, and there is a big table in the manual that shows you the various frequencies and pulse widths that you can adjust it to. So you can adjust it to weird baud rates if you want to, but I'm going to adjust this to 300 and 110. So that, in other words, we want 4,800 Hertz for the 300 baud and 1,760 for the 110, and we should be able to measure that at this point according to the schematic. So we'll power this up. 11.76 kilohertz, which is a bit on the high side. Okay, so we'll try the baud rate switch and see what happens. And that is much nearer, so it's 2,106. Now it should be 1,760, so we'll see if we can adjust the baud rate. We'll just check the correct pot, so it's low, which is VR3, which is this one, and we should be able to adjust that frequency, which we can, and we'll set it to 1,760. Okay, 1,760, so that's fine. We'll try putting it back onto the fast rate. So 11.76 kilohertz, so that's a bit strange. Seems to be a bit too far out. I'm wondering if the pot is possibly short or open. I'll try turning it and see what happens. Okay, so it just seemed to be a long way out of adjustments. It is adjusting, and we want 4,800. Okay, so what I'll do, they're currently at the right frequency or fairly close. Once it's been running for a while and had a chance to warm up, I'll come back and retest these, but I just wanted to see if it was running at all, and we'll just go back to the other frequency, and that's still correct. Okay, so they're both right. I'll just power it off. I can see I need to tighten this belt slightly further as well. And the next thing I want to do is to see if any of the keys are doing what they're supposed to. And in particular, we'll start with the feed key and the backspace key and see if we can drive this feed stepper motor. So I'll power it back up. We'll try feed. That's not doing anything, and neither is the backup key. We'll try the run key, and that seems to be permanently stuck to run. That one's actually working. It is toggling the reader run key, although nothing is actually plugged into the reader socket. Edit is actually doing, or appears to be doing what it should do. It's coming on briefly, then going off, and skip is doing the same. So these buttons might be working, but certainly none of these on the punch side seem to be doing what they're supposed to. Now it's possible I could disconnect the mains drive motor that's driving the punch head on this to quieten it down while I'm doing this testing. But if you recall, there is a timing device a pickup on the punch head that is supposed to be detecting the rotation of the punch head and the position. So what I'll do now is test to see if that's actually running, because it could be that it's not completing a step cycle and so not preparing itself for the next step. So I'll find the correct page in the schematic and we'll see what's going on there. Okay, so this is the part of the circuit we're interested in. We have the pickup coming in here. So it's filtered, squared up, and again we have a nice test point here to see if any of that signal is getting through. So I'll find this test point, we'll hook the scope to it and see what's going on. Okay, so it appears to be up there. And what we should see here is a non-symmetrical but square signal. So it should be a square wave but not a symmetrical one. So we'll power back up. Okay, and that appears to be picking up our signal. Good, so that's working. The next thing I want to do is try and figure out why the step key isn't working. So again, I'll try and find the relevant part of the schematic and we'll start off with the key panel itself. Okay, so this is the part of the schematic we're interested in, and in particular it's this feed switch that we're looking for. And so what we'll do is we'll monitor IC U2 pin 2, and we should see this switch when the key is pressed, and it should be active low by the look of it. And we'll see if that signal is present. Okay, so I'll power it back up. We'll monitor pin 2. I'll try pressing the feed key, and you can see on the scope it is indeed seeing the key being pressed. So at least we know that the key's working, and we also know that the inverter buffer is working, and so we need to look at the main board. Okay, so this is the next point we want to look at, and the signal should be coming in here when we are trying to feed the paper through. So we'll see if there's any signal coming through here at all. I'll start off with test point 8 and see if there's anything there. Okay, there we are. And we'll power up again and try pressing the key. And we are getting the signal here that we expect. It's a series of pulses, it should be stepping at a constant rate, and obviously it's not doing anything at all. But it is getting a reliable signal at that point. So we'll move on to the output of this particular gate. So that's IC C16 pin 3, and we'll see if we're getting anything there. This is laid out in a grid, by the way. It's A at the bottom and D at the top, and it's numbered from I believe 1 from left to right. So it's quite nice, it's quite easy to find the parts. And as I say, we're looking for IC C16, and that is the third row up. And they are numbered, and it's the one just under test point 8, which is not surprising. So we'll start off looking at pin 1, that's the test point we were just looking at, and make sure we get the same signal there that we were seeing at test point 8. Okay, so that's fine. And now pin 3. And we're getting a signal there. So what we'll do now is just follow it through and see what's going on. This is the entire drive circuit, by the way, for this. And it's just a couple of flip-flops that are being used to generate the 4 phases required to drive the stepper. So it could be these transistors aren't working, but we'll follow this through and try and find out what's going on here. And so next thing to look at is IC, you won't be able to see this, but it's B16 pin 3. So B16, B16 pin 3, press the key, and we're getting a signal there. So the next point is the output of that buffer, which is pin 2, so B16 pin 2, and as I say, all I'm doing here is following it through and seeing if we're getting the right thing, and that doesn't look right. It's not low and it's not high, so make sure we've got the right pin. Try 3 again, it's fine. Pin 2, which should be the inverse of pin 3, and so that's not working. Okay, so we've got through as far as this point. This buffer is obviously failed, and it seems to be used in several other places as well, so this may well be causing other issues if the entire IC has failed. So what I'll do now is I'll get this IC out of the board, I'll fit a socket, try a replacement device, and see if we can get any further. What we're trying to do is toggle these two flip-flops to get the phase to change that's driving the stepper. If we can get it changing here, I haven't actually tested this yet, but I'm starting at this point. If we can get through and we're getting signals here, then we'll know that the transistors are burnt out. Incidentally, I know the stepper works. I have got a stepper tester. It's basically just a ROM and some driver transistors and a counter, and I did try driving this, and that works fine, so I know the stepper's working. Could be an open circuit in the cable, of course, but as I say, we'll work our way through, and the next step is to get this buffer changed, because we know it has failed. Okay, so I've replaced that device, and I've got the old one here, and as you can see, it tests faulty. So these testers, by the way, I've shown this before, are quite useful. This particular device, it's a series of buffers, and it's used in quite a few places in the circuit, and I did use the scope and check a few of the other gates, and they seem to have failed as well. Now this only gives me a go, no-go for the device, so while these are quite useful, they do have their limitations. I do have another IC tester that I use, which is this one, and this does much more thorough diagnostics of the device. So we'll test it in here, and we'll do a run, and as you can see, it's also giving a fail. The difference is with this is it will tell me in what ways it's failed, which pins are giving the wrong outputs, and in what way the output's wrong, whether it's tied high, tied low, that sort of thing. So these are quite useful for doing more in-depth testing of devices, and also this is programmable, so you can set the thresholds. So these cheap testers are fine, but one thing I've found with them is that sometimes they'll give you a indication of a faulty device that's actually fine, whereas on here it would give you the proper indication as to the condition. So just be careful with these. They can give you false failures and false passes as well. Sometimes it will show a device has not been faulty, that isn't working. Okay, so I've got this device replaced. I've fitted a new one, and we'll now try and power this up and see if it works. Just a quick note, I've been asked to point out when I'm doing things like this where I have the ground connected, because when I'm scoping this, you've noticed that I don't usually have a ground lead attached to the probe I'm using. I'll attach them if I need to take accurate signal readings or if it's high frequency, but for something like this, it's just more convenient not having the short earth strap, because I'd have to keep moving it around. So I actually have another probe attached to the scope, and I'm using the ground lead on that, and it's clipped directly to one of the large caps on the power supply. So I am grounded, it's not all floating, and in this case that's where I'm attaching the ground wire. Okay, so we've got the device changed. What we're trying to fix, of course, was the circuit here. We weren't getting any stepping when we press the feed or reverse key, so we'll power this up. And when I press the feed key, hopefully we'll get some movement of the motor. If not, we'll trace further through the circuit. and hopefully you can see that the pulley is now rotating. So that's feeding out. That's if you want to create a leader, and if I press the backspace key, that is also now working. So that's actually cured two problems. It's giving us the forward and the reverse stepping for the main paper feed motor. Just turn that back off. And so what I'll do now is the same thing. As I said, I approach systems like this in a different way to microprocessor driven systems. In something like this, because all the circuits tend to interact, it's far easier to just work through each individual circuit block and see if it's working. So as we did here, work through this block until this block is working, and then I can move on to the next block and then the next one. So we've already done the clock, we've now done the main stepper drive, and so the next thing I'll do is move on and look at the various timings. We've got some hold off timing here for the various functions. Obviously when something occurs in a mechanical system, there has to be some type of time control for that function to allow the mechanical parts to actually move. And that's what a lot of these circuits are. They're just simple timers, and they're triggered to do a certain task, and once the task is finished they give a pulse out and it triggers the next part of the circuit. So it does mean that a lot of this interacts, and that's why it's, if you're trying to fault find, it's easier just to go through the blocks in their entirety and make sure they're working. If you want to see more of this sort of testing, then let me know. Otherwise I'll just work through this off camera and get back onto the next video once I've got the fault sorted out, and we can move on to the next block. In this case that would be the reader. But as I say, if you want to see more of the testing and fault finding on this board, then please leave a comment.